This is Brian Putt. Today I'd like to talk to you about doing a decision analysis using simulation. For this example, we're going to look at how to travel to the airport. This was actually an analysis I did for myself because I traveled a great deal to the airport when working for Chevron. We're going to look at a number of different options. So let's look at the decision hierarchy. This is one of your primary DA tools. So the top group of comments are givens. So it's given that we have to go to the Oakland airport and not San Jose or San Francisco, for example. And we have to get back from that airport as opposed to going out of Oakland and coming back into San Jose and then coming home. We're not going to take a rental car from the airport because there's a premium for renting a car at the airport. We will consider taking a rental car from Fremont, however. We're not going to drive to BART and park because if I'm going to do that, I might as well just park at the airport. The focus decisions we're going to have are how do we get there? How do we get to the airport? And then how do we get back from the airport? There's some tactical decisions that we'll decide later, where to rent a car, whether to use Uber or Lyft, and what cab company to use if we go with that option. So given the decision hierarchy, we can now generate a strategy table. We do that by identifying the decisions up here at the top, and we identify the alternatives for each of those decisions down here. So if I go to the airport, I could drive, I could get a rental car, I could get Uber, or I could take BART. In returning from the airport, I could drive, take Uber or BART. You notice I left off the rental car because that was part of our decision hierarchy, and given we would not take a rental car. I can then identify various strategies. So strategy one is drive and park and then drive home. Strategy two, when I would take a rental car and maybe take BART home. I could take strategy three, take BART there and BART back. Always a question about the reliability of BART getting to the airport, not so concerned about coming back. In strategy four, I could take an Uber there and a BART back to save some money. In strategy five, I just go Uber both ways. So those are the 5 strategies. Now, we have to understand the uncertainties involved. So let's take the rental car as an example. What is the time uncertainty for using a rental car both ways? I have to pick up the rental car. I have to drive to the rental car return. I have somewhere along the line, I have to get gas, and I need to shuttle to the airport. On the cost side of this alternative, I have the cost of the rental and I have the cost of the gas. And for each one of these uncertainties, I'm going to identify a minimum, most likely, and maximum value, and then fit those to a triangular distribution. There are some other uncertainties that we're going to need in the model, like how many days is the trip? If I drove myself, would I park for 1 day or 6 days or whatever? There's the wear and tear in the car. I need to know the miles to the airport. And maybe as a sensitivity, we'll ask the question, what is the value of my time? So we'll look at that at the end. So with that, let's flip over to the model. So here's the model. I've set up this model where we can either use probabilistic results, or if we want to, we can look at the most likely cases. And oftentimes this is a way to get a feeling for how optimistic the inputs might be. Let's stick with the yes here. We have the trip length. Let's default that to 4 days, or maybe I used 6 days before, so I'll keep it at 6. Airport miles is 20, mileage reimbursement 50 cents, and time value money we'll set as 0 initially. So what we've done here in this model is we've broken down each of the alternatives into pieces. So if I drive my own vehicle both ways, I have the time on the freeway, I have time to park the parking lot, time from the terminal to the parking lot and home. I have time on the freeway, and then so if in a round trip in this particular case, it took 86 minutes. And if I go to my SIPmath tools, I should be able to do some trial information here, and we should be able to see different answers if I've done this right. There we go. 92, 91, 100, 104, so forth. Okay? Go down to our rental car. We got the same sort of thing. Time to get the car, time to drive, gas for the rental car, so forth and so on. Take BART. I've got time there to get to the BART station and then get to the Coliseum. So you break these projects down into components. And then if I was to take Uber or Lyft, there's the time for the Uber to arrive. And these are the minutes. And this is the minimum, the most likely, and the max. And that's true for all of these up here. I should have said that. And then there's the time to drive to the airport. Okay? And here I'm saying I'm going to drive as a carpool. So driving with Uber might take less time than driving myself, is the point. Okay? Then we've got to come down here, and there's the cost. We've broken it down into the components there of the cost. And then down here, we've got the deterministic results. This is really for one simulation. If I want to see a different simulation, I think I can do this. Say here's driving my own vehicle, the cost is the same. Taking Uber, it should maybe be a different number here. There we see different numbers coming up down here. Okay? And then I have the expected values. So now down here are some graphs. And this is where I really encourage you to learn about cumulative distribution functions and how to interpret them, because they're most useful in really interpreting a lot of different alternatives here. Okay? So here's the cost for a 6-day trip. If I take BART one way, it's about $18, I guess. And there's no uncertainty in there. There's the Uber both ways is this purple line. Cost of Uber to BART is over here. And here's here's Uber both ways. Oh, the black line was rental car and BART home. Rental car and BART home is the black, and this is the Uber both ways. So I got these charts, but how do I kind of compare them? How do I make a decision with all that? Because really this is a comparison of the cost of getting to the airport versus the time it takes. So what I did, came down here and generated a chart that is a cross plot of the minutes round trip versus the EV cost for 6 days. So what you'd really like is something that doesn't take any time, it doesn't cost anything. So this is good down here, and this is bad up here. So something that takes less time and costs less is preferred to any other alternative like this, where it costs more and takes more time. So clearly we can cross off the rental car. But the Uber BART return, although it takes less time, costs more, and same with this one. And over here, I think this is the same. Driving to the airport is inferior to Uber both ways. So driving to the airport I can eliminate from my alternatives. So now the question might be, well, does the decision change if I change the length of the trip? Okay, so let's do this. Let me split my screen here. I think I can just split it right here. And we're going to take this to the top. And there's the 6 days. And then we'll come down here and look at this graph. So what if I did a 1-day trip, just to take an extreme? Whoa! Now driving to the airport is really superior. It's superior to this one, superior to that one, superior to that one. And I would now have to make a decision whether I was willing to pay at a premium of $40 to maybe save 20 minutes. That would be my trade-off here. So I think at this point in time, I'd probably drive to the airport. So let's put this back to 6. So now let's ask the question, how high would my time value of money have to be before I'd be willing to switch? So let me put in, let's say 30, this is dollars per hour. Let me put in $30. And you can see that Uber both ways came down, and Uber BART returned, so it's not um, still not equal. Let's put in 40, 50. Oh no, this is right. All right, 40 looks pretty good. Now both of these are the same, and I would prefer to Uber both ways rather than taking Uber and BART. And if I wanted to take just BART both ways and try to get that down, I'd have to maybe put in a higher number. Let's see if I can do that. I don't know if I can. 40, 60. They're about there, about $60. I put my value of time at $60. I could certainly eliminate taking BART as well. So anyway, you can see how you can do these sensitivities and determine what is the break even. So this is kind of your basic simulation looking at different alternatives. This is a nice chart here to look at a couple of different value measures and figure your trade-offs. So I'd encourage you to think about using these graphics for making decisions, along with, as I mentioned, using these cumulative distribution charts. And you see this is now different because we've got some different inputs up here. So if I put this back to 0, we'll be back to where we were. Okay? Thank you for watching. If you'd like to learn more about SIPmath, I suggest you visit probabilitymanagement.org. They have a wonderful website with all kinds of tools there shown down here, who they are. You can download models, and there's tools down here to include the SIPmath toolbar itself. You might also read The Flaw of Averages by Sam Savage. And please visit my YouTube channel. I have over 80 videos that cover a wide range of topics to include uses of the SIPmath tools, how to use the icons, cost and schedule risk analysis, portfolio analysis, value of information, lots of videos on that, and some mind testers. Hope you enjoy. Thank you.